further towards our last business session, that is role of technology in sustainable growth. Our first speaker for the session is Shri J.B. Suhag sir. I request Shri Chirag sir to present the memento and the bouquets. Shri J.B. Suhag is a mechanical engineer at first class boiler proficiency engineer from Gujarat Boiler Board. Currently he is working at Thermal Power Consultant at Techno Power and earlier associate with Rebo Industries Limited. Our second speaker is Shri Ram Shankar. I request Shri Anas Sheikh to present the memento and flower bouquet. He has done bachelor degree in medical engineering, ASME, NDE, level 11 years of experience in various aspects of concept to commissioning of all air pollution control equipments. He is the member in Policy Maker Forum for Air Pollution Control Norms. Without any further ado, I request Joshi sir for the opening remarks.
I understand and very much appreciate the presence of these many people. આખો દિવસ બેસવું અને આટલું બધું ટેકનિકલી સાંભળવું અને એ પણ અલગ અલગ વિષયોવાળું. આપણા પોતાના ડાયરેક્ટ વિષયનું હોય તો કદાચ હજી વધારે ઇન્ટરેસ્ટ પણ પડે, પરંતુ પેલું કહે ને કે સિંહના ટોળા ના હોય એટલે હવે જે છેલ્લે બેઠેલા છે એ બધા આ ફિલ્ડના સિંહ થવાના છે એવું માનીને તમને બધાને ફરીથી આવકારું છું. અને see, role of technology, we are talking about sustainable growth. There is a difference between circular economy and sustainable growth. We need to have a balance of the two. We need to combine both of things. And there are a lot of different things being done in the industry on the sustainable front as well as on the circular economy front. Someday in times to come, when circular economy model will grow up to fully complement or supplement sustainability, ત્યારે we will be able to reach the global sustainability goals that have been set forth by the UN in times to come. So it is very important to understand the role of technology. And Mr. Suhag, he is like Mr. Yadav. Mr. Yadav was earlier in the energy and now into waste. He was earlier into waste and also now into energy. They have a combination of a lot of experience. So he comes with such kind of a background. And my gentleman here, Ram Shankar, he has been into the field of pollution control for a very long time. And both of them have products, projects and procedures to use technology. So Mr. Suhag is going to share with us one of his waste to energy solutions, particularly in the agro field. Suhag sir, please.
Thank you, Dharmendra bhai. And Saket also inviting me here to speak some waste to energy solution or experience particularly in the field. I am from the field like you. Some of you are working as a manager, engineer. Like that, I work with the industry, so many industries, as an engineer, as a manager, as a senior manager, GM, and so I want to share my experience or recently what is the innovations as contributing to the circular economy by industries or by our growth or by our whatever the past experience we are involving in the future projects. તો બીજું હું આભાર માનું છું કે મને સૌથી સળગતા જે છે ટોપિક એ જ આપવામાં આવે છે સાકેતમાં જ્યારે બી, કેમ કે એમને ખબર છે કે સાહેબને આ ટાઈમે આપીએ કે જેમાં અડધા તો ઊંઘતા હોય અને અડધા ભાગી ગયા હોય, તો એમને જગાડવા માટે કે સાહેબને બરાબર છે એવા ટાઈમે આપણે ટોપિક સળગતા આપીએ તો કે બધા જાગી બી જાય અને જે ઊંઘતા હોય આ એકદમ એલર્ટ થઈ જાય જાગવાના મૂડમાં. તો મને આજે જે ટોપિક આપવામાં આવ્યું હતું અથવા તો મેં જે સિલેક્ટ કર્યું હતું કે જે આપણે સાંભળીએ છીએ કે પરાળી 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 પાસ્ટ ઘણા વર્ષોમાં આપણે સાંભળતા હોઈશું. સાંભળીએ છીએ કે નહીં આપણે પરાળી વિશે? જ્યારે સપ્ટેમ્બર ઓક્ટોબર નવેમ્બર મંથ આવે એટલે બધાને એ પ્રોબ્લેમ જે છે નોર્થમાં ખાસ કરીને કે ભાઈ પેલી ગવર્મેન્ટ પેલા ઉપર નાખે ને પેલી ગવર્મેન્ટ પેલા ઉપર નાખે ને પછી એમ કે દિલ્હીમાં તો હવે જવું જ નહીં, અથવા દિલ્હીમાં જવું બહુ મુશ્કેલનું કામ થઈ ગયું છે. બરાબર ને? એવા વર્ડ આપણે સાંભળેલા છે, પણ અત્યારે આ વર્ષે આપણે સંભળાયું નથી. કેમ સંભળાયું કે નહીં? ના સંભળાયું. એનું કારણ છે. તો સૌથી પહેલાં વોટ ઇઝ ધ પરાળી મીન્સ રાઈસ સ્ટ્રો. જે આપણે મેક્ઝિમમ જે નોર્ધન જે છે યુપી છે, હરિયાણા એન્ડ ધીસ પંજાબ, they are the most populated growing of the rice, right? And the rice growing, whatever the rice is cutting down from the top of the shredding, that is being the bottom portion of that part is called a parali, which is nowhere used. Why these northern peoples are not using, managing this straw or parali, and southern side they are also growing this rice, but we have never heard any news from the parali issue or any this pollution issue. Why it is so? The main thing is that whatever the rice quality and what is the rice straw quality is different than southern region than the northern region. એમના જે એનિમલ્સ છે ને ગુટકાવાળા છે અને પેલી બાજુના જે એનિમલ્સ છે ને ગુટકાવાળા વગરના છે. સમજ્યા ને ડિફરન્સ? એમનો ટેસ્ટ જે છે પરાલીનો ટેસ્ટ નથી, એમને પરાલી ભાવતી નથી નોર્ધન સાઈડવાળા. અને સાઉધર્ન સાઈડવાળા ઇવન આપણે ગુજરાતના જે એનિમલ્સ છે દે આર યુઝ ટુ this for this straw in the cattle feeding, right? અથવા તો animal feeding. But northern side the animals are not taking this straw or the rice residue in the use. So that is the main issue in the northern side. Okay, what to do with this rice straw? And the main challenge for that, okay, they are not having that much time in between two crops. બે ફસલ હોય ને જ્યારે રાઈસની ફસલ છે અને એના પછી જે છે આવે છે ઘઉંની, એની બંનેનું વચ્ચેનો ટાઈમ, their time in between these two crops is very very less. So that is also a challenge for the northern region farmers, what to do with this parali. See the pictures what we are also seeing in the news or somewhere like that. The farmers are forced to burn this energy. This is the energy they are burning, right? A big energy. So why parali burning in farms? Burning of rice stubble is widely practiced in the Haryana, UP and Punjab state of India, because burning is rapid and cheap option, right? It is a cheap option. કોઈ પણ વસ્તુને બાળવું હોય તો સૌથી ચીપ છે, પ્લાસ્ટિકને બાળવું હોય તો એ સૌથી ચીપ છે. બટ what are the effects of that burning is very huge and very dangerous. So but what there easy practice. Earlier no governments, no nothing were there. They are easily burning and they are managing the things with in between two crops. So it is very easy thing to but unknowingly they are creating a lot of pollution like this. The major reason behind the crop residue burning were due to the lower preference of the remittance in feeding combiner harvest, because they are not, earlier they were not having that type of machines to collect this residue. To collect that residue it requires a huge machining, huge cost also. Burning is very easy. If you are going to collect that residue, it takes a time as well as money. So that was the issue, that farmers were forced to burn this residue in their farms. Farmers set their fields on fire to quickly clear off the crop residue for the next sowing, because the time, as I told, the time in between first crop and second crop is very less, so they have to make it prepare for the next season. see that the smoke and in last few years government also has taken strict steps on the farmers, even penalizations also. So what they were doing in the night time, or sometimes they are managing like that, keeping the burning and leaving the farms like that only. So it creates a lot of issues. The burned by farmers to clear the field ahead of the sowing of the rapid crop. The shortened harvesting season, that is the main issue. The time between two seasons are very, very less. So that force them to burn and create and make it a rapid clearance from the second season. So what are the properties of parali? Means this rice straw. That is, rice straw is a density around 40 to 80 kg per cubic meter, carbon, hydrogen, sulfur, oxygen, nitrogen, moisture, ash and GCV. See, the GCV is very good. Gross calorific value is very good. Means it is the energy. Even with the lignite, we say, even some low grade coal, that is equivalent to that GCV is there. So it's a good amount of energy, but the main constituent of ash is the silica. As I told, why these animals are not liking to eat this parali in the northern region, due to the silica. Higher silica contents are there in their region rice. So that is the issue they are not using in the cattle field. Then other constituents are there. That is very less, but mainly is the 80% or 85%, up to 85% silica contents are there. So that is creating an issue for the farmers to make it used for animal feeding. So what are the issue with burning of parali in farms, right? Anyhow, there are no option to use this parali earlier, but unknowingly they are deteriorating their field, their soil, right? Because burning of farm waste causes several pollution of land and water on local as well as regional scale. It is estimated that burning of paddy straw result in nutrient losses 3.85 million tons of organic carbon, 59,000 tons of nitrogen, 20,000 tons of phosphorus and 34,000 tons of potassium. These all nutrients they are burning knowingly or unknowingly, right? Because they are not having any option. It results in the emission of smoke, which is effect gas present in the air like methane, nitrogen oxide, ammonia. Can you use several atmospheric pollution? The gases emission can result in the heart risk, aggregative asthma, chronic bronchitis and other disease, lung disease, right? Burning of crop residue also contributes indirectly to the increasing ozone pollution. So these all are the adverse effect of burning parali by farmers. Step to prevent parali burning. What are the steps? What are the remedial actions or the to reduce this parali burning? Carry out a detailed audit of the village level, material available, the root stable and the uses. Encourage rice growing farmers to dig out the stable using tractors, collect it. Again, it is costly, but again we have to have an option to collect it with the fodder and make it bundle. If we cut it and make it bundle, then easily it can be transportable. Otherwise, the bulk density is very low, so that is very difficult to transport it also. We cannot transport that rice straw from Punjab to Gujarat. It is not possible. Even in 100 kilometers or 200 kilometer transportation cost itself is very high. So that is the main issue of the, even if you make a bundle also, then also transportation cost is too high to transporting this good fuel for usable purpose. So that is one challenge for this parali use. The government can take garbage composite trucks on loan from the cities to collect. So again, as earlier speakers also told, that government should come in picture, so that may some help to reduce this cost to the farmers. Then compressed root stable should be transported and sold to the power station. That is manageable thing, But again, the power station or the energy source, from source to the power station, that distance should not be more. Otherwise, the transportation cost itself are very high, so they are unable to use this as a fuel. Brick kiln or distillizers for use as a fuel. The ash from these units should be returned to the rice field. Then it is a circular economy, because the ash, whatever the ash is generated, being generated by using this rice straw or parali, is being used as a fertilizer again to the farmers. So that ash again to the sent to the farmers at a very reasonable rate, then only it is viable to the farmers also. Then development of technology from waste to energy by burning rice paddy straw in steam boiler as a fuel and in power generation, that is the best solution. Now the government encourages this solution, and on the same, the reason is being that we are not, this year we have not heard much about the issues in the Delhi or in nearby areas, NCR areas, what is the effect of paralysis. So, government has taken a lot of initiation regarding this use of parali, and the main thing is to generate the energy, to generate the power or to generate the steam is the main and best utilization or waste to energy solution innovation, we can say. But again, there are a lot of challenges to use that parali into the boilers or into the steam generators and again to the power generation. So, reduce the dependence on the coal and other fossil fuel, right? Waste to energy means, again, if you use the parali, same amount of coal is not being not used in the steam generation or power generation. Steam produced can help meet the steam requirement to run the turbines and for the process requirement of the plant. Yeah, but that again is the issue that we have not to bring this parali from northern area to southern area or middle area. We have to set up the plants, set up the industry nearby only to use the parali or this waste. Replacing fossil fuel with the rice straw can reduce greenhouse gas emission, which prevents the pollution caused due to the stable burning. But definitely it will replace the burning issue or the pollution issue 100% by using this parali into the boilers and steam generators. But again, there are the challenges. Parali is not easy to burn in the boiler or in the combustors, because itself having some different technology also, boiler type also, and precautions also for burning of the parali. So rice straw has low carbon and high volatile combustion. Hence it is combust at lower temperature and result in fast devolatilization. That is the main issue. Then in right hand side you see that heavy ash deposition on pressure part. In boiler, when we burn this parali, the deposition of ash is very high. It is very difficult to remove, and sticky one to remove from the pressure part, means where the boiler pressure is generating, that pressure part is getting deposited with the high slag deposition of the ash. Then high corrosion and erosion of the pressure part and auxiliaries, right? Because the ash, the silica contents is very high, and it is nature of abrasion nature of ash. So it is very difficult and to prevent these pressure parts from the high erosion of the ash. So that is also a challenge for this using this parali into the boiler. Storage, land availability parali, and issues occurring to the fuel feeding system is again a very challenging, because it requires a very huge area. Means આપણે ખેતરના ખેતર જોઈએ એને સ્ટોરેજ માટે. Even it comes in the bundles or bales, then also we need a huge storage area to and again it is a seasonable. આજે એક season પતી ગઈ પછી શું? We are not having an option. So that is required a huge storage. By in season, we have to stock it and then use throughout the year. So that is also a challenge for using such this parali as a fuel. So complex fuel feeding and ash handling system again to maintain. It require a difficult fuel feeding system. As in the earlier slide, if you see, that is the conveyor is taking these bundles directly to the boiler. These conveyors are taking, this conveyor is taking a bundle of the parali directly in feeding into the boilers. So that is again a challenging. Ash collection, emission of that to reduce is also a challenge, because otherwise again it is creating an issue to the environment. So material selection, the pressure part material and other selection is also very much expensive looking to the normal boiler. So all these issues if we overcome, then definitely these parali combustors or still the boilers are running nicely in the northern region area and generating a good amount of steam as well as good power generation at present. Number of power plants set up in this area, smaller capacity, medium capacity, and where the industry's steam requirements are there, they are generating the steam with this waste only. Is there waste only, because the fuel cost is very, very low. When the cost of the coal is 10,000 or 12,000 rupees a ton, that parali is only 100 rupees a ton. 100, 200 rupees a ton. See the difference. If they generate the steam with 100 or 200 rupees ton fuel and we are generating here 10,000 rupees ton steam, then what is the difference in cost, right? So what the industry growth? So definitely that type of fuel or that type of technology we have to adapt, but the limitation is you have to use at source. You have to use at source. Where it is generating, you have to use and make it as a profit. This is the advanced technology. We have adopted advanced technology to overcome all the challenges what I told. Okay, it is creating a issue in the pressure part, combustion area, then erosion area, and this emission. These are all challenges we have overcome by the advanced technology and with the advancement in the boiler itself. So thermal boilers are designed with the superheater to take care of fouling due to the ash low deformation temperature. The radiant and platen design means high temperature and wide pitch of the fabricated, means specialized steel we can use to accommodate this parali burning. The combustion system is designed considering thermal expansion and everything, fuel ratio, air, because air is also very, very much less required compared with the fossil fuel burning. So this all overcomes the wear and tear and the abrasion part of the boiler. To increase the life of the pressure part, we have to go with the alloy steel and other area so that life of the boiler or steam generator may be increased. Then this is the special technology we cannot burn with the conventional boiler. This reciprocating grate or pulsating grate or pulse jet type of grades that may use for these parali fired boilers. So indigenous technology, single drum, natural circulation, big furnace, 3-pass boilers with the radiant superheater. These are the new technology adopted for particularly to burn a parali in the boiler. Designed for continue uninterrupted operation. It is not like that the boiler may give an interruption. Then your industry, total industry may suffer if it is uninterrupted, means interruption will be there. So no need of chipping or shredding of the fuel. The best advantage is that parali, whether it is coming in the 1 meter or 500 mm piece, it is not to be shredded. It is directly used in the boiler as it is. So that is the biggest advantage of this fuel. No shredding, no separation, no segregation is required. No segregation, no separation, nothing, no shredding. So this is the biggest advantage of this fuel. You can use as it is in the furnace. Then economizer with the fuel cooling system as low temperature zone. That is again different design is required, special type of coating of the economizer, because the main effect of the erosion part in the economizer itself. So in the air predator also some different technology is required, and the metallurgy, as I told, is of special grade material to be used for this such type of boiler. Then advantage of paralified steam boilers, that is saving benefit in the fuel cost. As I told, it is a very cheaper fuel available in that area. No, if it is not in our area, but in that area, it is very cheap fuel available. Then low capital cost, the project cost of this rice straw boilers is very cheaper than the others. Then high efficiency of rice paddy straw fired boiler system. Efficiency is also very high. Government initiation, now government has also favorable response and giving the incentive also, and by using the biomass as a fuel, that is also advantage of this. So with this, again I am very much thankful to all of you. Thank you very much. And this is the innovation in the circular economy by technology and adoption of our industries and benefit to the industries. Thank you. Thank you very much.
Thank you so much, sir. With that, we are moving towards our last speaker of the session, that is Shri Ram Shankar. I request you to deliver your speech.
A very fine good afternoon to one and all, and thank you for giving me this opportunity to Saket and the industry people of Ahmedabad. And I come from Unicon, and we are an air pollution control company based out of India and it's in Tamil Nadu. And we are basically solving air pollution problems in various industries. Like, for example, the Parali problem in Punjab, we have solved that one such problem where a boiler is installed and we have given the air pollution control solutions. And we have solved air pollution problems of cement industry, steel industry, sugar, power, paper, you name it, we are there in that industry. And this being a waste management seminar, the approach in this particular presentation will be to cover the technologies available today for the waste management industry, where we are moving from waste to energy. So I am particularly going to talk about, in the waste to energy segment, what are the latest air pollution control technologies that are available and how they are being used. So before we get into it, I'll give a small brief. It's a 2-minute video about my company.
Every day, citizens around the world feel the increased need to reduce industrial air pollution. However, industrial growth is needed to cater the increased human needs. Unicon provides cutting-edge technology and services to protect the environment with their air pollution control solutions. Unicon is the market leader in air pollution control equipments. The company has been in the field of air pollution control for nearly 3 decades. With 3 state-of-the-art production houses, and with engineers having more than 30 years experience in the field. With over 100 employees committed towards a greener tomorrow, Unicon has grown leaps and bounds in the field of air pollution control. Unicon takes protecting the environment as top priority. Unicon's products are running successfully for the past 25 years in 18 countries across the globe. Unicon's electrostatic precipitators. Guaranteed emission of less than 10 mg. With over 100 successful running installation, over a wide variety of fuels in many industries. Bag houses and bag filters. Guaranteed emission of less than 5 mg. Reduced power consumption. Pneumatic conveying system. Dust can be conveyed up to 2 kilometers by dense phased conveying system through pipelines. Ammonia flue gas injection system. In collaboration with Atomic Energy. Patented technology to reduce SPM levels from 300 to 50 mg in coal-based thermal power plants. With just minor modifications to the existing ESP. Material handling systems. Rotary airlock valves. Clamshell gates. Double cone valves. Double flap valves. Screw and belt conveyor. Drag chain conveyor. Slide gates. Knife edge gates. Unicon also provides inspection and testing services.
So I'll just skip to the part of where it comes to the waste management. So right now, in a waste to energy incineration application, the Pollution Control Board, the CPCB, has formed these norms where the particulate matter emissions, PM 2.5 and PM 10, shall not be more than 50 milligrams per normal meter cube. And there are various regulations for CO, sulfuric oxides and nitrogen oxides. So in a general incineration process, this is what you will generally see. The municipal solid waste that is being collected goes through a segregation process, and then it goes through a refuse derived fuel. It is being converted. The municipal solid waste is converted into something called as RDF, and that RDF is fired in incineration grade fired boilers. And here is where as a citizen, we have a responsibility. If the segregation at source is phenomenal, the calorific value of an RDF could be as high as 3,300 GCV, which could be very, very good. But right now in India, the gross calorific values of the RDF that we are getting from our waste, municipal solid waste, is 2,100 GCV. So kind of we are losing about 30-35% efficiency in the fuel, even though if we are burning. So we are losing a lot. So the stress and importance has to be on how much we are segregating our waste at our homes or at our source. That is the most important thing. And then comes once all that is combustion and everything is done. So these are the common pollutants that are generated out of firing these RDF or MSW. So first is the sulfuric oxides and the hydrochlorides, and then we have the dioxins, and then we have the particulate matters, and then we have the NOx. So these are the 4 major pollutants that are there when this application takes place. And how it is being treated in conventional methods, right, or even the latest technologies, say, for SOx, we have something called as a scrubbing technology or a flue gas desulfurization technology, where we go ahead with lime dosing. And in that also there are dry, semi-dry and wet, 3 different applications depending on the kind of fuel and the kind of source of limestone that we have. And for dioxins treating, there is a activated carbon injection technology that is available. And for particulate matters, there is ESP or back filters, which are conventionally used across all other industries also. And for NOx, nitrogen oxide reduction, we have something called as the SNCR or the SCR, where ammonia or urea is used as a reagent. Now, coming towards here, an ESP is an electrostatic equipment. Basically, we would all heard in our school times, electroplating, positive, negative. So a high voltage is passed and dust particles are basically collected. And you can see with this technology, emission levels can be reduced up to 10 milligrams. What I mean by 10 milligrams is this particular auditorium would have an emission or a particulate matter PM would be more than 30 milligrams or something. Anything below 100 milligrams is not visible to the naked eye, right? So the government norms today for incineration is only asking for 50 milligrams. But industrial technology is available to control or collect the dust and only leave out only till 10 milligrams. And that also because that is unfilterable particulate matters. All the filterable particulate matters are being filtered. So 99.99% is the efficiency of the equipments available today in the market to purify the dust that come out of these incineration applications. Coming towards back filters or fabric filters, these are even more advanced technologies than the ESPs, where the emission levels can go up to 5 milligrams. So we can only 5 milligrams will be emitted out of the chimney, which is as low as our own skin cells, right? We have dead skin cells in our body, which is in that, this particular room will have more than 5 milligram of dead skin cells from our own human body. So the efficiency of these equipments, the technology available today is far more advanced than what the governmental norms require. So like when we talk about we have to reduce 2.8 degrees or 1.5 degrees and all, the technology is there. The problem is we are not able to implement them because the segregation at source is poor. So we have all sorts of pollutants when we are firing and all sorts of complications that come along with it. And right now, I don't know how many of your industry people, but I will leave you with this. Many of you are using these back filters in your applications, but generally the Indian approach is, okay, I have to put up a plant, I have to burn this fuel, I have to create energy or something. So we will decide what is the cost of the equipment. But we don't see what is the cost of the ownership of the equipment. Here comes the point of the circular economy again, because we try to prolong the period of the equipment. Like, for example, the media selection in a particular equipment could be like, the equipment capital cost could be, let us say, 1 crore rupees or something, or 50 lakh rupees, anything for that matter. But we have to see what happens eventually. What is the efficiency of that system? How much power consumption does it take? Or what is the lifetime of that particular equipment? Today there are latest technologies available that are specifically designed for these membrane filter bags, which are specifically designed for waste to energy applications, where the equipment life or the guarantee, as a manufacturer, we give 5 years of guarantee with a pressure drop of less than 100 millimeter of water column. Normally these equipments will have a pressure drop of 150 to 200 millimeter of water column. So this payback, if they go ahead with the right, if they choose the correct equipment or the correct filter media, the payback will be in less than 2 years. How much they are spending more, they could get that money in 2 years, and they will have more plant availability and less complications and better efficiency of the systems. And this is not being incentivized in our country today because we don't have a carbon offset or a carbon incentive in our country as a policy. In foreign markets that is available. Imagine you are having a plant and you are having a plant. And if your plant is having a better efficiency, that credit, you can give it back to this company who is having a poorer equipment on air pollution control, and you can get incentivized from the government or from the other company who is running a little inferior air pollution control technology machinery. Because as a country in the COP summit, COP27, we have committed that we will reduce so much amount of carbon or particulate emission. So as a country, we have to look at this and we have to reduce. It's not that the bigger companies invest in these huge technologies and bring emission levels to 10 milligrams. The smaller companies may not be able to afford them, but the incentivizing scheme is not available, or the carbon offset is not available in our country. You can see when you are booking flight tickets, you will see, do you want to offset the carbon footprint? There is options available in the flight when you book the flight tickets. So these are available, but it is not available to the industry and it is not available in the policy level. So these things could help us in choosing where bigger companies, leave out the MSMEs, the larger companies in the industries can invest in these equipments in the state-of-the-art technology and offset these for an incentive from the smaller companies, so that the smaller companies don't have the burden of capital expense or the financing for that part. And in a general setup, so I don't want to get into too many details, but in a general setup, so again, there is something called for NOx reduction. We go into ammonia or urea injection. So NOx is basically generated between a particular temperature range. There is a critical temperature. So between these temperatures, the NOx is generated. Less than that or above that, the NOx is not generated. But the combustion happens at that temperature only. Suhagji will tell you, when you want to burn something, you need that temperature. And it's so, at that level, you have to inject the particular reagents, where the efficiency of the reagent, we reduce the reagent consumption, thereby maintaining the pollution levels also. And various details to it. But right now, there is another technology where we are combining the NOx catalytic filters and the back filters into one called as a catalytic filter. These are new developments in the market that comes from Europe, where the footprint of the whole equipment, the whole plant, instead of having 3 equipments, they can combine it into 2 equipments. And within the 2 equipments, the problems of particulate matter and the problems of NOx emission levels can be mitigated in one equipment itself. And this has a better environment impact, because when you run 2 machineries and you have too many reagents and too many chemicals to control NOx, here we are reducing all that. So the overall cost of impact that you are creating for the environment is also reduced, and your cost of maintenance of these equipments has also been reduced. So, but like anyway, whenever we solve a problem using a technology, we also create a smaller one. Like how we created plastic water bottles. We tried to solve the hygiene problem, we ended up creating a new one. So when we try to solve the problem of NOx, we create a problem of ammonia slip in the atmosphere. So care has to be taken by the plant maintenance, plant owners, and also by the regulatory authorities that this is monitored at every level to keep the ammonia slip and other problems to a minimal level. And these are known to the policymakers of the country, and many manufacturers or many representatives of manufacturers like me are part of the forum or part of the committee in where these pollution control norms are being regulated and formed. So these are debated before it becomes a law. So these are being debated at the government levels at various stages. And so the point I want to give to this forum is that from the technology side or from the industrial side, innovation is already available and it is at par with the regulations or whatever the country has committed to a global level that we will bring down our emissions. So in a nation building effort or in a global saving effort, the technologies are available today. The only thing is the industry has to step up and the government has to support in the policy level. And many companies like where I work, and many companies are available in the market too, with even better technologies. So I'd like to thank you for the opportunity given, and have a great evening. Thank you.
A final call for questions to any of the speakers here. Yes.
Thank you, sir. Thank you for sharing such a great information regarding that Parali issue and air pollution control techniques also. Sir, I have a question from both of you, sir. My first question is with JB Suhag San. Sir, if actually I heard somewhere that bioculture is there, certain bioculture is there for converting that Parali into the compost. If you spray that bioculture in the agriculture farm, then that the waste of that Parali will convert into the compost in the agriculture. If so, then why we need to burn into the boiler? Because if we burn, then certain limits of pollutant will release into the atmosphere.
You are absolutely right. This is also, this biocompost is also doing, this is also technology is there. But the amount of parali is too much, that is not, means it is not possible only with this, by doing the decomposition, means composition of this parali. So that is the quantity, the generation, and within short time of you have to remove from the farm. Okay. So that is only the issue.
And sir, as per solid waste management rule, actually industries are recommended to install the organic waste converter for their food waste that management. And in that, sir, as a raw material, certain sawdust is required to control that moisture content of food waste. Yeah. So can we use that parali waste as a sawdust in our organic waste converter as a
Again, the parali issue is the transportation. As I told, you have not to bring that parali from Punjab to here. Right. So we have to use in that source only. Otherwise, so it is going to be too costly. Right. One truck of parali, if you bring from Punjab here, it is more than the cost of the fuel. Means what you are looking for. Right, right. That is the issue. That is the issue.
Thank you, sir. Thank you, sir.
Thank you.
Sir, my second question is Ram Shankar san. Sir, actually I am from the automobile industry, and we are facing a lot of issue with the VOC emissions because we have a painting activities in our manufacturing process. And but sir, actually VOC is a very crucial gas which is also play an important role in the GHG emissions. And if so, then why government is not why government is not prescribing any norms for the VOC emission in the atmosphere? And what are the technologies available for the VOC that absorption? If any technology is there, then please let us know, sir.
Actually, the government has policies for VOCs, but not specifically for automobile industry. There is a VOC pollution norms available from the CPCB guideline for the petroleum industry and refinery industry. because the VOCs from petroleum and refinery is much more in quantity in comparison with the automobile industry, where the VOC is coming from the painting basically.
Yes.
Correct? So the technology available is something called as thermal oxidizers. So thermal oxidizers are the best technologies available in the market today, which will bring the VOC levels also to less than 50 milligram per nm cube or something, which is again not visible to the human eye level. So it will look like as if it is not even there. So the technology is available. If you have any problem with the thermal VOC, organic compounds, you can contact me. I can share my card after this discussion, and I can take you to my counterparts in Italy who have this particular technology, and you can approach them directly and they can give you the solution.
Thank you so much, sir. Thank
But
you.
again, I am saying it is a very costly
It's a highly costly
solution.
equipment.
Cost is
Very
not
costly
matter.
solution.
Cost is not matter, but in industry, safety is a major concern.
Yeah.
And sir, I think thermal oxidizer is very like it's a atom bomb kind of things.
Yes.
If I am not wrong, sir.
Yes.
No, you are
So
right.
like that's the reason I said, even though thermal oxidizer manufacturer is available in the country, I said I'll connect you to my counterpart in Italy where you can buy it from there. Because you said you're from the automobile industry, I'm sure your industry can afford that cost or something, that you can buy a good equipment from proven technology suppliers and vendors, because it's going to cost a bomb and it's also a very critical equipment to maintain. It's not easy. The maintenance procedure and SOP for a thermal oxidizer is pretty long and exhaustive. So your maintenance team may not be happy about it, but as a whole, you're solving a bigger problem. Yeah.
Thank you, sir. Thank you so much.
Thank
sir.
you.
Yeah, any question from the back side, yeah? It is an interaction session, yeah. We are not to just કે સાંભળીને આપણે જતા રહ્યા ઘરે. Come on, પાછળથી કઈ એક જ માણસ પૂછે છે ક્યારના. ધર્મેન્દ્રભાઈ પછી એમ કહેશે કે now we have to stop. કેમ કે એમને ખબર પડી જાય છે કોઈ હલતા નથી એમ પૂછવા માટે. અને હું દરેક સેમિનારમાં દરેકમાં હું કહું છું કે મેક ઇટ એ ઇન્ટરેક્શન સેશન, નોટ જસ્ટ અમે આપી રહ્યા છે ને તમે લઈ લીધું ને પતી ગયું, અહીંથી જતા રહ્યા ભૂલી ગયા બધું. હું પૂછું પછી કહીને કોઈને ના પૂછવું હોય તો, કેમ કે મારી હેબિટ એવી છે કે કોઈ ના પૂછે તો હું પૂછું પછી. એટલે શરૂઆત મેં સૌથી પહેલાં મેં જ કહી હતી ક્વેશ્ચન આન્સર સેશનની કે કમસે કમ બુસ્ટઅપ થાય લોકો. આપણે અહીંયા શું બાયોમાસ ફ્યુઅલ આપણે વિચારી શકીએ જે આપણે ઇન્ડસ્ટ્રીને આપી શકીએ એવું કંઈ છે કોઈના ધ્યાનમાં? ગુજરાતની પર્ટિક્યુલરની વાત કરીએ. વી આર મોસ્ટલી ડિપેન્ડિંગ ઓન ધ ઇન્ડોનેશિયન કોલ ઓર કોલ ઓનલી. ઇટ ઇઝ ઓનલી ધ ચીપર ફ્યુઅલ અવેલેબલ ઇન ગુજરાત. છે કોઈ? હવે આ મારો ક્વેશ્ચન છે તમને બધાને.
ગાંડા બાવળનું છે ને જે પ્લાન્ટેશન અત્યારે કરીને એમાંથી જો ફ્યુઅલ બનાવવામાં આવે અથવા એટલે એને જે આપણી અત્યારે એકચ્યુઅલી પ્રોબ્લેમ છે આપણા માટે
ગુડ.
સૌરાષ્ટ્રમાં અને આખા ગુજરાતની અંદર જે ગાંડો બાવળ છે એને જો એમાંથી કંઈક એવી ઇનોવેટિવ પ્રોડક્ટ બનાવવામાં આવે કે જે એઝ એ ફ્યુઅલ ઉપયોગ થઈ શકે, કારણ કે એનું લાકડામાં ઘણું ટેનિન હોય છે જેનું સારી રીતે એનું સળગાવી શકાય છે, તો દેટ કેન બી ડન.
ગુડ ગુડ. આવી રીતે જવાબ આપો. બીજા કોઈ?
એક્ઝિક્યુટ કરી રહ્યા છે
ઓકે.
અને એમને ESP જોઈતું હતું, મારા ટચમાં છે.
હા.
અને મોરબીના એમને પોતાને સિરામિક ફેક્ટરીને બધું છે.
ઓકે.
હવે અને પ્રોજેક્ટ બી કમ્પ્લીટ થવા આવ્યો હતો, પણ પછી આ કોરોનાના 2 વર્ષથી બધું ડિલે થયેલું છે. પણ એમને કીધું જંગલી બાવળ બેઝ અને એમાં પોલ્યુશન ને બધું ક્લિયરન્સ કમ્પ્લીટ મળી ગયેલું છે એમને.
ઓકે. પાછળથી બેક સાઈડ.
જે એરંડાની ડી ઓઇલ કેક આવે છે એ પણ સબસ્ટિટ્યૂટ છે, કેસ્ટર DOC કહેવાય છે એને.
ગુડ ગુડ. ઇટ્સ ઓલ્સો એ ગુડ ફ્યુઅલ. અગેન બટ અગેન ધ ક્વોન્ટિટી, બટ રાઇટલી સે કે જેટલી ક્વોન્ટિટી જ્યારે અવેલેબલ હોય, જે અવેલેબલ હોય, વી હેવ ટુ યુટિલાઇઝ. એવું નથી કે ભાઈ આપણે ચલો DOC બહુ ક્વોન્ટિટી ઓછી ક્વોન્ટિટીમાં મળે છે, પણ એનું યુટિલાઇઝ કરવું જોઈએ. બરાબર. અને ડી ઓઇલ કેક મોસ્ટલી કેમ આપણે ફ્યુઅલ તરીકે યુઝ નથી કરતા એ બી કહું, કેમ કે એનું વધારે પડતું આપણે કેટલ ફીડમાં જાય છે. અને પછી જો કેટલ ફીડમાં ના વપરાતું હોય ને પછી જો એક્સેસ રહેતું હોય તો જ આપણે એનો ફ્યુઅલમાં યુઝ કરવો જોઈએ. જે હું સમજું છું. રાઈટ? બીજું કંઈ ભાઈ? ગુડ, થેન્ક યુ. પાછળથી આ બાજુથી આપણા પાકિસ્તાનવાળા નથી ભાઈ, ઇન્ડિયાવાળા જ છીએ. આપો એ બાજુ આપો બેન, તમે કોઈને આપો. પૂછો, કંઈક તો પૂછો, નહીં તો પછી ધર્મેન્દ્રભાઈને કહું છું હવે બંધ કરો. Any fuel in your mind in Gujarat?
Sir, it's possible to promote cultivation of Jatropha. I think it's called Ratanjyut in local language. So if we promote the cultivation of Jatropha, we can better outcome for it.
It becomes a good fuel, what you rightly say. Yes, thank you. પાછળ આ બાજુ આ લાઈનમાં.
હમણાં જે સાહેબે વાત કરી તો આમાં પ્રીવિયસ પ્લાન્ટમાં અમે આપણે જે મગફળીના જે ફોતળા આવે ને એનાથી અમે બોઇલર ચલાવતા, મતલબ
રાઈટ.
ત્યાં કોલસાની ઘણી અસર થતી ટ્રાન્સપોર્ટેશનના ચાર્જના લીધે.
હા, રાઈટ, ગુડ. તો જો આવી રીતે આપણે પોસિબિલિટી છે તો થોડું માઇન્ડ આપણે દોડાવીએ કે ભાઈ ચલો જ્યારે મળે કોસ્ટમાં પરવડતું હોય, જેમ કહ્યું એમના મગફળીના ફોતરા કહ્યું કે એ પણ જે ક્વોન્ટિટીમાં રાજકોટ સાઈડ કે આપણે એ રિજનમાં યુઝ કરી શકીએ. રાઈટ? અને 110 છે કે જ્યાં 100 મિલો હોય એની આજુબાજુમાં આપણે ક્યાંક નજીકમાં આપણી ઇન્ડસ્ટ્રી હોય તો એ યુઝ કરવું જોઈએ. તો વેરેવર ધ ફ્યુઅલ આપણે, ટ્રાન્સપોર્ટેશન ઇઝ ધ મેઇન થિંગ. એવું ફ્યુઅલને આપણે બહુ દૂર સુધી ના લઈ શકીએ, પણ નજીકમાં જ્યાં અવેલેબલ હોય ત્યાં આપણે એનો યુઝ કરવો જોઈએ, ઇન્સ્ટેડ ઓફ આપણે સોલિડ ફ્યુઅલ કે આપણે કોલ ઉપર જઈને આપણે અનનેસેસરી એન્વાયરમેન્ટને આપણે એ કરી રહ્યા છીએ. સો વિથ ધીસ, થેન્ક યુ વેરી મચ. ધર્મેન્દ્રજી, સમ અપ નાઉ.
I will only take 5 minutes. આ સેશનની અંદર once again there were two things which I specifically remarked. One was on the side of the government's job, that there was a suggestion which Ram Shankarji made to incentivize the carbon offset. I believe that's a very valid point, and industries here need to get together, and through your industry associations or chambers of commerce, I believe we should start a dialogue with the government, suggesting them that some procedure needs to be laid down to incentivize carbon offsets. If you feel like, you can send us some such proposal which we can forward to the government, to the GPCB, and on behalf of the industries. We cannot do it on behalf of Saket because Saket would not have a voice. It would be the industry which would have a voice. So if it comes from the industry, we could definitely take it up to the authorities, and maybe in time to come, because it will take a lot of discussions and a lot of considerations before putting up such kind of a incentive, and maybe we can start the process. There was one other thing which came up, and which was, while we consider product cost for any of the products that we all manufacture or sell, one component needs to be the cost of environmental impact that we make.
Also the cost of ownership.
Cost of ownership.
We never consider that. I mean,
I absolutely agree to that. I believe all of you should go back and, try to see if your company considers that cost into the costings. That is very, very, very important point that has come up. Circular economy is not just for our core industries. આપણે બધા માનતા હોઈએ કે ડાઇઝ એન્ડ કેમિકલ્સ ને આ ને તે ને એવી બધી ઇન્ડસ્ટ્રીઝમાં સર્ક્યુલર ઇકોનોમીની વાત કરીએ, બટ these speakers have given us examples where circular economy is being used even for the agriculture industry. It is just about applying the knowledge. There are systems, there are procedures, there are technologies, but as engineers or as entrepreneurs or as technologists or as professionals, what we need to actually do is how we can use that knowledge into practical applications to resolve problems. Circular economy has been implemented for economic purposes for hundreds of years in India. આપણે એ પણ વાત કરી કે શર્ટમાંથી છેક આપણે રજાઈ સુધી પહોંચ્યા અને રજાઈમાંથી છેક પોતા સુધી પહોંચી ગયા. We have been doing that. We have been trying to reuse as much as possible. કાકાના રમકડા ભત્રીજાએ વાપર્યા હોય એવા આપણે ત્યાં દાખલાઓ છે. પેઢી દર પેઢી રમકડા વાપરતા હોઈએ આપણે. We have been doing that for hundreds of years. Industrial history is rich with examples of industrial symbiosis. આ વર્ડ કદાચ તમે બધાએ સાંભળ્યો હશે. Industrial symbiosis, where one byproduct from something or one waste from something is being used by the different industries. And we have, during the day, come across many such examples. Byproducts from one industry form inputs for other industries. They may be sustainable, but they can also contribute to locking in unsustainable material systems, such as the network of petrochemical industry infrastructure, many aspects of which are now considered essential for social and economic reasons. But the relation between circular economy and sustainable development is weak as on date, and it is debatable. However, circular economy can definitely contribute positively to most of the sustainable development goals. But sustainable development and circular economy are on diverging pathways. While the sustainable development agenda puts people front and center with economic prosperity recognized as a means for living fulfilling lives in harmony with nature, circular economy remains fixated on technological solutions, implementation of which is driven by a promise of traditional economic growth. We need to balance both these things. Circular economy must be fully integrated with sustainable development. This necessitates a profound reconsideration of the principles of circular economy, broadening its scope from closed loop recycling and short-term economic gains towards a more transformed economy that organizes access to resources to maintain or enhance social well-being and environmental quality. Superficial changes will not suffice. Every actor, every one of us, should do their very best to develop a more sustainable circular economy, not acting upon the destabilizing environment, societies and economies due to our unsustainable resource use. It is not an option. But there will be failure and it will never be perfect. We have to accept this, yet not be discouraged to act. Sustainable development is fraught with imperfection, and so is circular economy too. The critics on circular economy should be understood as much as a critic on sustainable development itself, and both require research and constant learning to ensure progress towards sustainability. I believe at the end of the day here, the effort at Saket was just to ignite a thought in our mind, just to ignite a spark in a few people's minds to think about this more, and in times to come, India should become the leader while we talk about sustainable development and circular economy. I think we have tried our best as the organizers to make this happen, and it's now a collective effort of every one of us which is required. At the end, I thank everyone here for being with us throughout the day, especially each one of you who even after 4:15, right from 9 in the morning, are with us. And we will definitely be organizing these conferences every year as we normally do. And we look forward to you all being here once again the next year when we organize this conference. On behalf of all of you, I also thank the two guests here, Mr. Suhag and Mr. Ram Shankar, and of course the entire expert panel that we had during the day for sharing their valuable knowledge and sparing their valuable time with us. Thank you to you, to all our sponsors, all our supporters, all our organizing team from Saket, and every one of you to have made this conference a very successful conference. Thank you very much. I would request everyone to rise for the national anthem before we end the day. जन गण मन अधिनायक जय हे भारत भाग्य विधाता, पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा, विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा, तव शुभ नामे जागे तव शुभ आशीष मांगे, गाहे तव जय गाथा, जन गण मंगलदायक जय हे भारत भाग्य विधाता, जय हे जय हे जय हे जय 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 हे. Thank you.